Hello, hi everyone. Welcome to the Student the Brand. Today I am going to discuss about light reflection and refraction. Light reflection, refraction. So complete chapter. So you can see now. So I am going to discuss light reflection and refraction complete chapter. So you can note down. I'll be explaining one by one, topic wise. So I'll be getting no. If you have any doubts, you can do comment in the comment section below. So now shall we start? Today, what is the topic? Light reflection and refraction. So we are going with the electricity topic. So how we have to discuss and where it will start. So everything we'll discuss now. So light is a form of energy which gives sensation of sight. Hello, hi everyone. Welcome to the Student the Brand. This is your Shiva sir. So now we are going to discuss about light reflection and refraction. Light reflection and refraction. Okay. So now you can see here I am talking about light reflection and refraction light reflection and refraction completely we'll discuss about it, completely we'll talk about it. So light is a form of energy. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives sensation of sight. Clear? Correct? Huh? Yes or no? Yes. So normally sound, if you can see, sound is a form of energy which gives sensation of hearing. There it will be sound. Here we are talking about completely about light. Light is a form of energy which gives the sensation of sight. So we can able to see. Okay. So how we can able to see? When light falls on it, then only we can able to see. When light incident on it, then it will reflect back and reaching to your eyes. Then we can able to see. Light is a form of energy which gives the sensation of sight. That is called light. Okay, so now we'll talk about reflection of light. Reflection of light. I'm taking, this is the plane mirror. I'm considering this is a plane mirror like this. So on it, light is incidenting. This is incident ray. The light which is incidenting on the surface. This will be the reflected ray. This I am considering the incident ray, reflected ray. And the line which is perpendicular to the plane surface, this is called normal line. Incident ray, reflected ray, normal line. Okay, so incident ray, reflected ray, normal line. And I am considering this a deviated line, undeviated line, undeviated line, undeviated line, undeviated line, undeviated line, or initial direction of the incident ray. Initial direction of the incident ray. So I'll be giving the notes also. Okay, so those who want this notes, you can note down, make a note of it. Okay, write down once. So very important concept, complete topic we are discussing. It will take time. Okay, I'll try to complete. So if it is today class, otherwise, so I'll take in the next class. Today light reflection tomorrow refraction, like that we'll discuss. Human eye and colorful word, still it is going on. So human eye and colorful word, and electricity, magnet effects, electric current, like that. So topic wise we will discuss, topic wise. So those are attending the class, so stay connected with the class, stay connected with the Student the Brand channel. Definitely you'll get a good and very nice content. So CBSE grade 10 physics. At the same time, here this is also helpful for grade 12 students, those are writing present. So present, those are studying. For them also it is optics chapter is there. In optics chapter we'll discuss all these topics. So it will be helpful. Even whatever we are discussing grade 10 topics also as it is, so it will be there in grade 12. Okay, and grade 11 students, so already started. So one of the student asked, so okay, so she asked, so one of the student asked, so that's why I created the playlist and I started working on it also. Grade 11 students, so you can check my playlist. You can go to the playlist, Student the Brand playlist. So there 3000 short videos are there, very short. So like 15 seconds, 11 seconds, 10 seconds. So very good content, you will get it. Like all basics you'll get it. So that will be helpful for grade 11, grade 12, and presently who are writing this year, who are going to write. So NEET and JEE, and upcoming 2017 students also, 2025, 26 and 27 students. 2026 and 27 students. So who are writing JEE and NEET, so whatever content is there in my channel, so in playlist, so you can check. 3000 videos are available. You can utilize that content. And grade 10 students, I created the playlist. You can go to the playlist. So nearly 60 videos are there. So recently I created one more video, 52 minutes. Okay, that will be helpful to you. Complete light reflection. And those are writing JEE, NEET, for them also I created. So 90 videos are there. So 90 problems are there. So you can practice once. So that will be helpful a lot. So now we are going to discuss about light reflection. Okay. So this is the incident ray, reflected ray, and I am considering undeviated line or initial direction of the incident ray. Initial direction of the incident ray. The angle between incident ray and normal line is called angle of incident. Angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. Angle of deviation. I am trying my level best to create a good content that will be helpful to the students, and immediately they can concentrate, immediately they can focus, immediately at least they will get interest. Okay, the best policy of learning is so to create interest on something. Okay, if you want to learn something, you should have interest. Without interest, we can't able to work on it. Yes or no? So that's why to create interest, I am creating my level best. I am doing my level best. So if you like this video, so you can do like, share, and subscribe my channel for more better content. Okay, so more like the videos. So surely I will be developing. I am working on it. Okay, so if you like this, please do like, share, and subscribe. So that is only one thing I am asking. So thank you so much. Please do support. Please do support my channel. Okay. So this is incident ray, reflected ray, normal line. This is the undeviated line. Incident ray, reflected ray, normal line. This is undeviated line. Okay. So now undeviated line I am considering. Laws of reflection will discuss. Laws of reflection. Laws of reflection. So what are the laws of reflection? Laws of reflection is nothing but, so angle of incidence is equal to angle of reflection, and the second one, incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Okay. So next one, this is about laws of reflection. Next one, angle of deviation will discuss. Angle of deviation. Here, reflection is nothing but the bouncing back of the light. The bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. So this is the, what is this one? Plane surface. So this is the plane surface I am considering. This is the plane surface. Plane surface. Plane surface. Plane surface. Plane mirror I am considering. Plane mirror. Plane mirror. This is a plane mirror. Okay. So this is a highly polished smooth surface. Highly polished smooth surface, that is called plane mirror I am considering. Now, so angle of deviation, so actually it is a, so linear angle 180 degrees. Linear angle is 180 degrees. That is nothing but angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of incidence equal to angle of reflection. From that I am taking angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. 2 angle of incidence. So that is, and also angle of deviation can be written like this. So angle of deviation we can write, so 180 minus 2 angle of reflection. 2 angle of reflection, 180 minus 2 angle of reflection. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. So this is about angle of deviation. So reflection, light reflection. The light incident, this incident ray. The light which is incident on the surface is called incident ray. The light which is reflecting back is called reflected ray. The light which is perpendicular to the surface, that is called normal line. Incident ray, reflected ray, normal line. So the bouncing back of the light is called reflection. The bouncing back of the light is called reflection. Coming to laws of reflection, angle of incident equal to angle of reflection. Incident ray, reflected ray, normal line lies on the same plane. Okay. So angle of deviation, so if you are taking this linear angle is 180 degrees. So angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees I am considering. Okay. So here instead of angle of reflection I am taking angle of incidence. From this one, angle of incidence is equal to angle of reflection, right? Instead of this one I am considering angle of, instead of angle of reflection I am taking angle of incidence. So angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. So angle of deviation equal to 180 minus 2 angle of reflection. So both ways we can take. And coming to the next one, will go with the regular reflection and irregular reflection. Regular and irregular reflection. Okay, so I'm considering now regular and irregular reflection. Regular reflection means I'm taking the plane mirror like this. So I'm considering the plane mirror. If the incident beam is like this is incident ray, this also incident ray, and this also incident ray. Then the reflected ray like this is a reflected ray, reflected ray, reflected ray. Okay. Incident beam is parallel, reflected beam also parallel. Then this type of reflection is called regular reflection. Regular reflection. Regular reflection. Coming to irregular reflection. So regular reflection takes place on smooth surface. This is the smooth surface. So smooth surface. Smooth surface. Okay, so it is also called plane mirror. So example, I am taking the plane mirror. This is a plane mirror. Plane mirror. Okay, so regular reflection takes place. Whereas irregular reflection, so I am considering second one, irregular reflection. So if you are taking the surface will be like this. If you are taking the surface will be like this. So incident, I am taking, these are the incident rays. These are the incident rays. So this is also incident ray. This is also incident ray. But reflector light rays are not parallel to each other. Reflector light rays will move in different directions. Okay. So incident beam is parallel, but reflected beam is not parallel. So irregular surface. This surface is called irregular surface. Irregular surface, and this type of reflection is called irregular reflection. Irregular reflection. Irregular reflection. Irregular reflection. So clear? So regular reflection takes place on smooth surface. So this is a smooth surface, plane mirror. Incident beam is parallel, reflected beam also parallel. Here incident beam is parallel, reflected beam is not parallel. This type of reflection is called irregular reflection. Okay. Next one will go with the object and image. Coming to the object and image. Object and image. So I am considering plane mirror like this. This is a plane mirror. This is the plane mirror I am considering here. So object like this. Okay, so one object I am taking. So here is the object, a real object. Light rays are coming like this, and here also light rays are coming. After reflection, light rays will move away from it. Here, light rays will move away from it. Then, if you are extending these light rays, light rays will meet at one point here. So I am considering light rays will meet at one point. So here I am considering like this. Okay. So here you can observe. So here you can. Light rays I am taking. How many light rays are required to form the image of the object? Minimum 2 light rays. How many light rays are required to form the image of the object? Minimum 2 light rays. So here is the object, real object I am taking. So we are extending this reflector light rays. So here virtual will form. What type of image will form? Virtual image. What type of image will form? Virtual image. Virtual image will form. Virtual image will form. Object is real. Object is real. Image is virtual. Object is real. Image is virtual. And second case I am taking. So you can see the second case. So one more case I am taking here. So mirror. So here is the object. So here light rays are coming from infinity. I am taking like this. Light rays are coming from infinity like this. So if you are extending this incident rays, so incident rays are meeting at one point. Here is the real image. Image will be real. Here virtual object. So real image and virtual object. So here real object and virtual image. So we can conclude that by this object and image. Object is real, image is virtual. Object is virtual, image is real. So this is about object and image. Image is real, object is virtual. Object is virtual, image is real. So we can take like this. Okay. So if one is real, another one is virtual. If one is virtual, another one is real. So very important. Here one more definition I will explain. So listen carefully. The point of intersection of incident rays. The point of intersection of incident rays is called real object. The point of intersection of extended reflector light rays. This is the reflector light ray. This is also reflector light ray. So we are extending this reflector light ray. Those light rays are meeting at one point on the principal axis. So these two are reflector light rays. These two are reflector light rays. Those reflector light rays are meeting at one point on the principal axis. These are the reflector light rays. These are the reflector light rays. Reflector ray, reflector ray. So after reflection, those light rays will meet at one point on the principal axis. That is called a virtual image. Here the point of intersection of actual reflector light rays. Reflector light rays are directly meeting at one point. So this is reflector ray, this is reflector ray. Reflector light rays are directly meeting at one point. So that's why it is called real image. So if you are extending this incident rays, those incident rays are meeting at one point on the principal axis. So that is the virtual object. Virtual object. So that is about real image, virtual object. So I hope it is clear. Next one. So we'll go with the next one. So plane mirror. Plane mirror I am considering. Plane mirror. There are so many points are there. So coming to the plane mirror like this. So mirror I am considering. Mirror, mirror, plane mirror. So I am taking the plane mirror here. So line I am considering. Okay. So object is placed here. Object is placed here. One object. Object height is AB. This is AB height. Okay. So how many light rays are required to form the image of the object? Minimum 2 light rays. So that's why I am taking. So this is A. So this is a B. One light ray I am taking like this. So it will be reflected. So if your light ray is passing along the normal line, so how it will be incident? If it is incident on it, will be reflected in the same direction. If it is incident along the normal line, it reflect back into the same direction. Here also, if it is reflected, so reflect back into the same path. One, I am considering here one more. It will be reflected back. and one more I am considering along this one. So if you take here, okay, so it will be reflected back. Then if you are extending that light ray, if you are extending that light ray, if you are extending this light ray, okay, so here I am considering, so like this, if you are extending this reflector light ray, if you are extending this reflector light ray, so image will form here, so image will form here, okay. So object is here, object A dash, B dash, so reflected ray, so those reflector light rays are meeting at one point, okay. So first point is height of the object is equal to height of the image, height of the object is equal to height of the image, height of the object is equal to height of the image, again height of the object is equal to height of the image. Second one, so object distance, what is object distance? The distance between object to mirror is called object distance. The distance between object to mirror is called object distance. The distance between object to image, image to mirror, the distance between object to mirror is called object distance. The distance between image to mirror, the distance between image to mirror is called image distance. Once again, the distance between object to mirror is called object distance. The distance between mirror to image is called image distance. So object distance is equal to image distance. Object distance is equal to image distance. And the third one is, it shows lateral inversion. Lateral inversion. Lateral inversion. Lateral inversion. What is the lateral inversion? The phenomena of converting of left side of C. Here I am if you are seeing the mirror, so mirror reflection. Okay. So our right side object appears to be left side object appears to be right side. So mirror image is right side object appears to be left side object appears to be right side. So that is a mirror image. Okay. So we are considering the mirror image. This converting right side to left side to right side, object appears to be left side of the image, left side of the object appears to be right side of the image. So this type of mirror reflection is called lateral inversion. Okay, so lateral inversion. So these 3 points are very, very important. So keep in mind, 3 marks question. And the next one will go with that. One more. So I have completed related to plane mirror, all points are completed. So now I will discuss about spherical mirror. So now I am going to discuss about spherical mirror. Spherical mirror. So coming to spherical mirror. Spherical mirror means I am taking this is a sphere. So small portion. So sphere I am considering like this. So if you are taking a small portion, that is called curvature. Small portion is called curvature. Okay, it depends on reflection. So if it is reflecting inward, that is called concave mirror. Reflection takes place inward, that is called concave mirror. Reflection takes place inward, that is called concave mirror. This is a concave mirror. Concave mirror. Concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Converging mirror. Concave mirror is also known as converging mirror. Whereas convex mirror is also known as diverging mirror. So convex, if you see, this is a convex mirror. So pole. So okay, anyway, that points I'll discuss. So meanwhile, you can check once. So reflection takes place outward. reflection takes place outward. This is called a convex mirror. Convex mirror. Convex mirror is also known as diverging mirror. Diverging mirror, because reflection takes place outward. So here why it is converging, why it is diverging. Converging means after reflection light rays will move towards the principal axis. So light rays are coming closer, light rays are moving towards the principal axis. Here light rays are moving away from the principal axis. Light rays are moving away. Light rays are moving away from the principal axis. That's why it is called diverging light rays, diverging mirror. Okay, so I hope it is clear. Next one. So we'll go with the spherical mirror terms. Next one I will explain the spherical mirror terms. Terms is spherical mirror. Terms is in the spherical mirror. What are the terms we used in the spherical mirror? Terms is spherical mirror. I am considering the concave mirror like this. Optic center. Oh, sorry. This is not optic center. Concave mirror. I am taking this a concave mirror. Here, coating will be like this. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. Actually, it is a part of the sphere. So, it's a part of the sphere. So, the midpoint of the mirror is called pole. The center of the imaginary sphere. The center of the imaginary sphere in which mirror is a part. So, this is the center of the imaginary sphere in which mirror is a part, that is called center of curvature. The line joining of center of curvature and pole, that is called principal axis. First one is pole. So second one is center of curvature. Third one is principal axis. Principal axis. The line joining of center of curvature and pole is called principal axis. So fourth one, the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. Or fifth one, so after reflection light rays will meet at one point on the principal axis. After reflection light rays will meet one point. After reflection light rays will meet at one point on the principal axis, that is called focus, principal focus. Principal focus, or simply we can say focus. So, and the sixth one, the distance between focus to, so the distance between focus to pole is called focal length. So the distance between focus to pole is called focal length. I am considering this is focal length. Focal length, so with a small letter. Okay, so F. And width of the mirror, so what are the wherever reflecting taking place, so that mirror reflecting surface is called aperture. Aperture. Okay, so these are the 7 points. 7 points once again. So you can check once all the 7 points. What are those? Pole, the midpoint of the mirror, the center of the imaginary sphere in which mirror is a part, the line joining of center curvature and pole is called principal axis, the distance between center curvature to pole is called radius of curvature. So after reflection light rays will meet at one point on the principal axis, that is called focus. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And the width of the mirror or the reflecting surface is called aperture. reflecting surface is called aperture. So that is about terms related to spherical mirror. Next one will go with the ray rules. Ray rules. So ray rules I will discuss. Ray rules I am considering. So concave mirror. So about concave mirror ray rule I am discussing. So first one is, so I am taking the concave mirror like this. So here is the pole, focus, center of curvature, pole, focus, center of curvature. One light I am taking like this. After reflection it passes through focus. Second one light ray after reflection passes through focus. Second one, so pole, focus, center of curvature, pole, focus, center of curvature. So light ray passes through focus. After reflection passes towards infinity. Light ray is coming from infinity, after reflection passes through focus. Light ray is passing through focus, after reflection move towards infinity. And third one, so light ray third one, pole, focus, center of curvature. Light ray passes through center of curvature. After reflection retakes the original path. And the fourth one, so here I am considering pole, focus, center of curvature, pole, focus, center of curvature. Light ray incident at the pole, it reflect back. Light ray incident at the pole, it reflect back. Okay, so one light ray coming from infinity after reflection passes through focus. Another light ray passing through focus after reflection moves towards infinity. So light ray passes through center of curvature, it retraces its original path. Light ray incident at the pole, it reflects back like a reflection phenomena. Okay, so that is about ray rules. So even convex mirror also will be the same. Convex mirror also. So if you want, I will draw the convex mirror also. So I will show the convex mirror how it is. Okay. So convex mirror, I am considering the convex mirror also. If you are taking light ray like this, so reflection takes place outward. So here is the pole, focus, center of curvature. So one light ray coming from infinity after reflection passes through focus. So you have to draw. If you draw, it will passes through focus. Another light ray I am taking like this. So here itself. So pole, focus, center of curvature. Light ray is passing through focus like this. If you take, passes through focus, after reflection passes towards infinity. And here I am considering the concave mirror. So pole, focus, center of curvature, pole, focus, center of curvature. Light ray incident at the center of curvature. So it reflect back. So here it passes through center curvature. So if you are taking center curvature here, passes through center curvature. Okay, like that, passes through center curvature. Next one, we can see if the light ray incident at the pole. So I am considering the pole, focus, center curvature. Light ray incident the pole, it will reflect back. Okay, so these are about ray rules. Now I will discuss about image formations. Now I will discuss about image formations of mirror. concave mirror. Concave mirror, converging mirror, convex mirror, diverging mirror, concave mirror, converging mirror, convex mirror, diverging mirror, diverging mirror. Okay, so now we'll see ray rules, image formations. I'm taking the concave mirror. So pole, focus, center of curvature. Object is at infinity. One light ray I'm taking like this. So after reflection, light rays will meet at focus. Okay, like this. So image will form at focus. Nature of the image is real inverted. Size of the image is highly diminished. First one. Light rays are coming from infinity after reflection. So meet at focus. Second one I am taking. Second one I am considering pole, focus, center of curvature. Object is placed beyond center of curvature. Object is placed beyond center of curvature. One light ray I am taking like this. It passes through focus. Another light ray passes through optic center. So image will form between C and F. So image will form between C and F here. So image will form between C and F. So object is beyond 2F1. Object is beyond C. Actually, I'm thinking 2F1 lens, right? So it is in lens. Now here in mirror 2F1, image will form between C and F. Nature of the image is real inverted and size of the image is diminished. Compared to the object, image size is decreased. Next one, third one. Third image formation. So I am considering third image formation. So pole here, focus, center of curvature, pole, focus, center of curvature. Object is placed at C. Image also will form at C itself. So image also will form at C. Here I am taking. One light ray I am taking like this. It passes through focus. Another light ray I am taking. So it incident at the pole. So it reflect back. Then it will incident here. So center of curvature and pole, focus, center curvature and focus. Object is placed at C. Image will form at C. Nature of the image is real inverted and size is same size. Size is same size. Compared to the object, image is same size. Okay. So next one. So next one we'll discuss about between C and F. Image will form between C and F. So here I am considering. So fourth one. Image will form between C and F. So pole, focus, center curvature. Image will form between C and F. Here I am taking. One light ray I am taking. It passes through focus. Another light ray it will incident at the pole. It reflect. So image will form beyond here. Here image will form. Okay. Object is between C and F. Image will form beyond. nature of the image is real and inverted. Nature of the image is real and inverted. And coming to the size is so enlarged compared to the object, image size is increased. So fifth one, so I'm considering fifth one, object is placed, so pole, focus, center of curvature, object is placed at F. One light I am taking, passes through like this, another light I am taking, so it will reaches to infinity. Okay, object is placed at F, image will form at infinity, nature is real inverted, nature is real inverted, nature. Size is highly enlarged. So last one more last case is there, very very important case. So very very important case. So last case, you can see I am taking the last case. So optics and P, pole, focus, center of curvature. Object is placed between F and P. Object is placed between F and P. One light I am taking, passes through like this. Another light ray. So if you are extending this light ray, the image will form behind the mirror. Object between F and P, image will form behind the mirror. Nature of the image is virtual erect and enlarged. Okay, so this is about the last case. Clear? So next one. So sign conventions. Sign conventions, all measurements will be taken from the pole. So if you are taking a concave mirror like this, so first point is this is a pole, focus, center of curvature, all measurements will be considered from the pole. So in the direction of incident ray is positive, object image distance, focal length, radius of curvature are positive. Opposite incident rays, object distance, image distance, focal length and radius of curvature all are negative. Above the principal axis all are positive, height of the image and height of the object. Below the principal axis all are above the principal axis, height of the image and height of the object positive. Below the principal axis, height of the object and height of the image is negative. So all measurements will be taken from the pole. In the direction of incident ray is positive, opposite to incident ray is negative, above the principal axis positive, below the principal axis negative. Okay, so this is about sign conventions. So next one, mirror formula. Mirror formula we'll discuss. So mirror formula is 1 by f equal to 1 by v plus 1 by u. So lens formula magnification equal to minus v by u, height of the image by height of the object. Magnification is nothing but ratio of the Ratio of height of the image to height of the object, that is called magnification. So this is about light reflection. So because time is not no, supporting still, so now it is uh, almost 12 o'clock. So we'll see in the next video. Next video I will explain about light refraction complete. Okay, so this is about light reflection. So if you like this video, do like, share and subscribe to Student the Brand. And I already started the CBSE Grade 10 Physics course. Already started CBSE Grade 10 Physics course. Light reflection, refraction, humor in colorful world, magnet effects of electric current and electricity. These 4 chapters I am explaining. At the same time I am giving soft copy notes and 100 definitions from 4 chapters, 100 problems from electricity chapter. This all I am giving soft copy. So with the cost of 500 rupees, and if you have any doubts, further queries, you can contact to this number. So if you like this video, do like, share and subscribe to Student the Brand. Subscribe to Student the Brand, STB. Thank you.